Hi, so in this video I'll help you to solve problem 6 of homework 6 because there seems like a lot of students have problem for this one using the technology. So I decided to make a video to explain the question for you guys. Now let's take a look at this sample. A study was done on the skull size of human during different time periods. We have 4000 BC and 150 AD. Now we assume that the samples are independent, simple random samples, and this is also from the normal distribution population. We are asked to complete part A and B. For part A, they're asking us for the null and alternative hypothesis. So the null hypothesis is always that the two objects are being compared, they are always equal. So in this case, mu1 and mu2, they are equal. So there's only A, B, and D as the correct one. And then we look at the next one. The question is trying to test the claim that the 4000 BC is less than the 150 AD. Therefore, mu1 should be less than mu2 for the testing. And in these three cases, it's only D is mu1 less than mu2 for the testing, to test the claim, and the null hypothesis, they are always equal. So mu1 equal mu2. So in this case, D is the best choice. Now, after you have the null and alternative hypothesis, now let's do the test statistic T. So for the test statistic, let's go back to the formula that we had on section 9.3. So if you go back to page 459 in the textbook, then the test statistic has the formula as follow here. So Z equal to x1 bar minus x2 bar and minus mu1 minus mu2 over the square root of sigma 1 square over n1 plus sigma 2 square over n2. So this formula is the test statistic formula from page 459 in your textbook. So x1 bar and x2 bar are the mean we have here. So x1 bar is 130.72. So I go ahead and write that 130.72, and x2 bar is 133.24. Because we originally has mu1 and mu2, they are being equal. So if they are equal, then they subtract each other, you get 0. And then divide by the square root sigma 1 square. Sigma 1 square is just the standard deviation, which is 5.26 square, over n1 is the sample size for 4000, which is 32, and then plus for sigma 2 square, which is the standard deviation for 150 AD, or 5.27 square, and over n2, or the sample size for the second sample, which is 32 also. Now let's plug in all of this into the calculator and get the value. So 130, let's take the square root first. 5.26 square divide by 32 and add to 5.27 square divide by 32, and then take the whole square root of that, and then take the top 130.72, subtract 133.24 24 and then divide by the value we just got. So which is equal to minus 1.90. Okay, they asked us to round to 2 decimal places, so I got minus 1.91. So let's go back here, minus 1.91 for the test statistic. And let's check the answer now. Good. Now for the p-value. Okay, so after we got the test statistic, we can find a p-value. Okay, let me write this. Okay, so remember this one is we are given the alpha level to be 0.05, and we are testing for mu1 less than mu2. The arrow is pointing to the left, which is the left tail in this case. So let me draw the curve. Okay, so we are testing for the left tail, So I assume that something, we are looking for the area here, right? It's all up all the way to minus 1.91. So mu1 is less than mu2, so we are pointing to the left side, which is the left tail test. Now the p-value, we can use the TI-83 or 84, and you just have to enter the comment. So we're using the TCDF, and we are trying to find the area all the way to the left up to this point here. So I use a huge negative number, which is minus 10 to the 99. Just some huge number all the way to the negative side, and up to minus 1.91. And then the last input should be the degree of freedom, which is n minus 1, right? The degree of freedom. Now we have two samples, n1 and n2. So we have to pick the smaller of the degree of freedom. But in this case, n1 and n2, they are equal. They are all equal, so it's easy. So just 32 minus 1 or 31. Alright, so we go all the way from the negative side up to 1 to the test statistic minus 1.91, and then comma, and the degree of freedom. So let's try to use the TI-83 in this case. Okay, let's turn this on. Second verse here, and I go to TCDF, enter, and minus 10 to the 99, a huge negative number, comma, minus 1.91, and comma, the degree of freedom, which is 31. And that should equal to 0.03. They want us to round to 3 decimal places, so 0.033. Okay, so 0.033. Let me make sure that this is correct. 0.033. Okay, so check the answer. Perfect. Okay, so after we have this p-value, let's make the conclusion. Remember that the alpha is 0.05, and we have the p-value to be 0.033. So 0.033 is less than the alpha, right? The alpha is 0.05. So if we less than, that means we have to reject the null hypothesis because there is not sufficient evidence to conclude or to support the claim. Oops. Wait, reject the null hypothesis. Oh yeah, because sorry, we reject the null hypothesis because there is sufficient evidence that we cannot conclude that this one is less than the mu1 is less than mu2. Sorry, this should be A. Yeah, because if we reject, that means we have sufficient evidence to reject that. Right? Yeah, it's easy to confuse here. There are two cases for the reject. So we reject the null hypothesis because we have enough evidence, and I got the evidence from this guy here. We have the p-value, and the p-value is less than the alpha. That means we have sufficient evidence to support the claim that this one 4000 BC is less than 150. Okay. So right here we reject the null hypothesis. That means we say that mu1 and mu2 they are not equal, right? The null hypothesis states that mu1 and mu2 they are equal. Now we reject that. That means we say they are not equal. And if they are not equal, that means we have enough evidence or sufficient evidence to support the claim that this guy mu1 is less than mu2, or we say that the alternative hypothesis is good. Okay, yeah. So make sure to be careful not to make a wrong choice here, because they both say that we reject, but the second statement here, there's the not and there's what that are not, so it's easy to confuse. Now, so after you have everything for part A, part B is to ask you to construct a confidence interval to test the claim, the same claim we had earlier. So for the confidence interval, we have the formula for the confidence interval also in page 459. But I think that for this example, this question, my MATLAB is asking us to use the technology to test to find a confidence interval. So if you happen to use the formula in the textbook, you still got the answer that are similar to the one if by using the TI-83 or 84. But if you input that to here, my MATLAB may not give you the correct answer, or they may mark your answer to be wrong. So I highly recommend that for part B, we should use the TI-83 or 84 to find a confidence interval instead of the formula. But during the exam, you are free to use the formula. Now let's go back to the confidence interval. So if you want to use the confidence interval, let me pull out my TI-83. Where is it? Okay, it's here. Okay, so click turn on, and for confidence interval, go to the stats and go to the test here, and then you're gonna find two sample t interval. Okay, so two sample t interval here, and then click enter, and you want to choose the stats. Okay, so they ask you for the x1 and standard deviation and the sample size, the same thing for the second sample. And what else do they ask you? And for confidence interval and the poor, make sure you pick no in this type problem. Now let's go back to the question, the table here. So x1 bar in this case is 133 point. Okay, so 130.72, and then standard deviation of x1 or 5.26, and n1 should be 32, and x2 bar is 133.24, and standard deviation of the second sample is 5.27. Oops, 5.27, and the second sample size also 32. Okay, for the confidence level, remember this one is the one-tailed test, so you are actually finding the confidence interval of 1 minus 2 alpha confidence interval. Okay, so in this case we are given 0.05. We are only considering for one-tailed test, so we are trying to find the confidence interval of 1 minus 2 alpha. Alpha is 0.05, then 2 alpha 2 times 0.05, and 1 subtract that give you 0.9. 0.9. So alpha is 0.05. So 1 minus 2 alpha is 0.9. Right? 1 minus 2 times 0.05, which is 0.9. 0.9, which is what? 90%, right? 0.9 is 90%. Now, that means we are looking for the confidence interval of 90%. So go back to here, and you're gonna input, let me clear this one, 90% in this case, and then you go all the way down to calculate, and then press the enter. Okay, so we end up with the lower level, the lower bound to be minus 4.718. So I go back to here, minus 4.718, and then my upper bound should be minus, we want, okay, they want 3 decimal places, so minus 0.322, minus 0.322. Let me make sure that they're correct. Minus 4.12718 minus 0.322. Okay, so this should be our confidence interval for this example, and let's check the answer. And well done. Okay, so does the confidence interval support the conclusion of the test? Now, to answer this question, let's go back to, where's my, okay, here. Okay, so we have the claim is mu1 less than mu2. Okay, so if this is the case, then mu1 minus mu2, what is it? So I subtract mu2 on both sides, so mu1 minus mu2. If I bring this to the left side, then I end up with 0 on the right side. Okay, so this tells us that mu1 minus mu2, this is the claim that we are testing, mu1 minus mu2 should be less than 0. And now the confidence interval shows us that this value is between two different numbers, and these two numbers are all negative, which is less than 0. So this should be yes, because it's only negative value. Good. So that's how you answer this question from homework 6, and that is all, and thanks for watching.